Hi guys, I'm here to do lesson 6.4 with you. Your learning target for this lesson is I will be able to write expressions. So starting with your think about it. Write an expression to represent the written expression 12 less than a number. Explain how you came up with your expression. Go ahead and pause the video and see if you can figure it out, and then we'll come back together. All right guys, hopefully you paused your video. So I'm assuming you probably came up with one of two possible expressions. And my guess is that you came up with either 12 minus n or n minus 12. So looking at our text, we know that we have the number 12. And since 12 is standing by itself, we know that 12 is our constant. Okay, we have a keyword here, less than. And less than tells us that we are going to be using subtraction. Finally, we have a number, and that's where our variable is going to come in. And I used the variable n for this problem since it's saying number. You could have used any letter like X, Z, A, B, it doesn't matter. Okay, but this is going to end up being our variable. All right. So in both of these expressions that I wrote down here, we have a constant of 12. 12 is standing by itself. We have a variable of n, and we have a subtraction problem. So it looks like both of these are correct, but we have to determine which one is actually correct because only one of them is. So the best way that I think of solving this problem for you to get you to see which answer is correct is I'm going to draw a model for you, okay? First of all, when it says 12 less than a number, that's going to mean that I'm taking 12 away from a number. So I'm going to start by drawing these out. Okay, so say for this expression right here, okay, we have a big tape diagram or bar model, whichever you want to call it, okay? And this is going to represent, it's going to represent 12 because we're starting off with 12. Then it says that we need to subtract n. So I'm going to take a little piece of this, and this is going to be n. So our answer should be what is left here in this box. Okay, but it's a different bar model when we draw on the other side, when we have n first. When we have n first, our tape diagram is going to be n. So this is going to represent n. Then we take away some number 12. Okay, so I'm taking away this chunk and I'm taking away 12. So that leaves us with our answer, which is this remaining part here. So have you figured out which one is correct yet? Still maybe, I mean, do they represent the same thing? In this picture, we're starting with 12 and taking away n. And in this picture, we're starting with n and taking away 12. Coming back to our text, it says 12 less than a number. And we figured out that means we have to take 12 away from a number. So it's starting to look like this is going to be our correct expression. Another way we can do this is we can plug in a number for n. We can say, well, what if n is 20? So instead of writing n, I'll substitute for the number 20. So on this side, I'll have 12 minus 20. And on the right side, I'll have 20 minus 12. Okay, if I solve the left side, that ends up putting me in the negative side, and it would be negative 8. And on this side, we'd be left with 8. So which one is representing 12 less than a number? Is negative 8 12 less than 12?
No.
Is positive 8 12 less than 20?
Yes.
So it's our expression here on the right. It's important to note, guys, that you can't always go in the order that's written in the description. And that's what we did on this problem, because if you look at the order, it says 12, so we have 12 less than, we said that would be subtraction, so subtraction, a number n. And that didn't work out for us. Okay, so it's really important that you kind of try and either substitute a number or draw a picture for yourself to kind of help you figure out these expressions that you can use. So the final answer here, the correct answer, is n minus 12. All right, let's move on. So we have our key point. Mathematical situations can be translated into algebraic expressions. So when we see this word algebraic, all that means is you're going to start seeing variables. A numerical expression is where you're going to have an expression that just has numbers, but an algebraic expression is a number sentence that has variables in it. So starting with number 1, interaction with the new material. Write an algebraic expression that represents the description below. The quotient of 6 and a number n. So let's break this down. I see the word quotient. Quotient is the answer to a division problem. So this tells me that I'm going to have to divide. And we have the number 6, and we have a variable n. So n is our variable. So now, since we are working with division, we have to be very, very careful about the order. Because 12 divided by 6 equals 2. But 6 divided by 12 does not equal 2. It actually equals 1/2. So what I'm saying is you cannot just flip your numbers around during division. So it's very, very important that we pay attention to our order. So the first number that we're given is actually our total. And the second number, or our variable that we're given, ends up being our divisor. So it's super, super important to remember that order matters when it comes to division and actually subtraction as well, because here's another example with subtraction. 5 minus 3 equals 2. But if I flip these around and do 3 minus 5, that does not equal 2. That actually equals the complete opposite. It equals -2. Okay, so it's really important to pay attention to your order when you're working with division and when you're working with subtraction. So again, our final answer was 6 divided by n is what represents the written expression, the quotient of 6 and the number n. All right, example number 2. Which algebraic expression below represents 1/3 of a number b? Okay, so let's break this down. 1/3, that's a fraction. We have the letter b, which is going to be our variable. Okay, and when it says 1/3 of a number, that's actually representing multiplication. So it's representing multiplying 1/3 by a number, which we don't know what our number is, so they're using the letter b, or the variable b. So let's look at what we've got. So it says 1/3 plus b. Well, we determined that this represents multiplying a fraction. So we know that A is going to be incorrect. Okay, B, 1/3 times B. Well, it looks like I'm multiplying 1/3 and B together, so that looks correct. And I could draw a model to help me figure that out. So I'm taking B and I'm multiplying it by 1/3. In other words, I'm dividing B up into 3 equal sections. And the answer will be the value inside this one box that I just highlighted, because it's 1/3 of the diagram. Okay, let's continue with our choices. B divided by 1/3. This is incorrect. We're not dividing by a third. D, b divided by 3. Well, let's draw that out for a second. If I divide b, which is the length of this tape diagram, into 3 sections, that would tell me how much is in one section. Does this look like the same tape diagram we had for the letter B here? It sure does. So that expression also represents this algebraic or this written expression. Okay, finally, b minus 1/3. This is not a subtraction problem. We've determined it was a multiplication problem. Okay? So there's something I really want you guys to note here. Okay? Finding the fraction of a number is the same thing as multiplying the number by that fraction. And sometimes this can be represented with division as well, like in this case. And I'll tell you why this works, okay? So let me show you why both of these two represent the same expression. Okay, so we're going to plug in a number for b. Let's say b equals 6. Okay, so I'm going to plug it in on the expression we had for b here. So 1/3, okay, times 6. And in order to multiply those, I have to turn 6 into a fraction. So I have 1/3 times 6/1, and I just multiply straight across. 1 times 6 is 6, 3 times 1 is 3, and when I simplify that, I get an answer of 2. Now I'm going to plug the same value in for the expression we had for d. Okay, so we had b over 3. So I'm going to put b, which is 6 over 3. Remember, fractions are miniature division problems. So 6 divided by 3 equals 2. So notice we get the same answer whether we're multiplying by 1/3 or dividing by 3. All right, guys, I will see you in your Zoom meeting where we can work on your 1 and 2 star problems. We'll